K.Chandrasekar, Professor in the Department of Aeronautical Engineering in PSN College of Engineering and Technology. Today the topic is bulk deformation process. Actually, the deformation process is used in manufacturing of goods. First, the basic bulk deformation process are rolling, forging, extrusion, wire and bar drying. The rolling is in the rolling, slab or plate is squeezed between opposing rolls. So in between rolls, the slab will be kept and the product will be produced. Then the forging, the work is squeezed and shaped between opposing dies. In extrusion, the work is squeezed through a die opening, thereby taking the shape of the opening. While in wire and bar drying, the diameter of wire or bar is reduced to pulling it through a die opening, then we will get the final product. First we will see the rolling process. In deformation process, in which the work thickness is reduced by compressive forces exerted by two opposing rolls. So there will be two opposing rolls. The compressive forces is exerted by that rolls. When you kept the work between the rolls, we can give the compressive force on the work and we will get the final output, that is reducing of the thickness of the output. Rotating rolls perform two main functions: pull the work into the gap between them, friction by work part and rolls. Simultaneously squeeze the work to reduce its cross section, that is thickness. The types of rolling is based on workpiece. You can classify the rolling process into flat rolling and shape rolling. Based on the working temperature, you can classify the rolling process into hot rolling and cold rolling. Because the flat rolling means it is used to reduce thickness of a rectangular cross section. So when you use the rectangular cross section, you have to go for flat rolling. In shape rolling, shape cross section, square cross section is formed into a shape such as I-beam, like that. Based on the working temperature, we classify the hot rolling and cold rolling. Hot rolling is most common due to the large amount of deformation required. When you require the deformation amount is very large, then you have to go for hot rolling. In cold rolling, it produces finished sheet and plate stock. So this picture shows how the rolling products made from the steel. So in the left side, loom, slab, billet. These are the raw materials for the rolling process. The right side, the structural shapes, rails made up from looms. If you want to plate, sheet and coils, you have to use slabs, and billets can be used to produce bar and rods. This is a diagram of flat rolling. This is the side view of flat rolling. It is indicating before and after thickness, work velocities, angle of contact with rolls and other features. So this T0 is initial temperature, initial thickness of the workpiece. The TF is the finished thickness of the workpiece. So these are roll radius, contact length. These are the things, these are the parameters involved in the rolling. In shape rolling, work is deformed into a contoured cross section rather than a flat, that is a rectangle. It is accomplished by passing work through rolls that have the reverse of desired shape. Products includes construction shapes such as I-beams, L-beams, U-channels, rails for railroad tracks, round or square bars and rods. So most of the products can be produced from this shape rolling. This picture shows a rolling mill in a industry for hot flat rolling. The steel plate is seen as a glowing strip in lower left corner. This one. Rolling mills. The equipment is massive and expensive. The configuration of rolling mills are 2 high, 3 high, 4 high, cluster mill, tandem rolling mill. In 2 high rolling mill configuration, there will be 2 opposing rolls used for rolling process. In 3 high rolling mill configuration, the work is passed through rolls in both directions. In 4 high rolling mill configuration, so backing rolls support smaller work rolls. Cluster mill, multiple backing rolls on smaller rolls. Tandem rolling mill is sequence of 2 high rolling mills. So this is a configuration of 2 high rolling mill. There will be 2 rolls, they rotate in opposite direction, and the figure shows the process. So velocity, initial velocity, then final velocity of this 2 high rolling mill. This figure shows the 3 high rolling mill. There is 3 rolls are there. The first 2 rolls rotating opposite side. First work is initiated here. Then we take the product and the finished product come out from this VR, V2. 4 high rolling mill, there will be 4 rolls. The small roll, the bigger rolls are supported to these workpieces. This figure shows cluster mill. There will be multiple packing rolls, allow even smaller roll diameters. So from the cluster mills we can produce smaller diameters product. This in tandem rolling mill, there will be number of 2 high rolls configuration will be there. So combination of 2 high roll mills called tandem rolling mill. It will be arranged in sequence manner. The gap between the rolls will be vary from one roll to another roll. So you can reduce initially the thickness will be reduced, smaller amount of thickness will be reduced, then later it will be reduced very largely. Then after rolling process, you go for forging, the deformation process in which work is compressed between 2 dies. Here you are using 2 dies to form the deformation process. The components can be produced from the forgings are engine crankshaft, connecting rods, gears, aircraft structural component, jet engine turbines, and so on. Also, basic metals industries use forging to establish basic form of large parts that are subsequently machined to final shape and size. The classification of forging operations: cold versus hot forging. Hot or warm forging is one category, cold forging is another category. In hot or warm forging, most common due to the significant deformation and need to reduce strength and increase the ductility of the work metal, we have to go for hot or warm forging. In cold forging, the advantage is increased strength that results from strain hardening. So this is the cold forging versus hot forging, the differences. The next one is impact forging and press forging. So here we use the force hammer. It's applied an impact. So this is used in impact forging, whereas the press forging, forged press is used. It applies the gradual pressure to make a shape. Types of forging dies. The dies are used in forging can be classified in open die forging, impression die forging, flashless forging. In open die forging, the work is compressed between two flat dies, allowing metal to flow laterally with minimum constraint. So this is the open die forging. Impression die forging, the die contains cavity or impression that is imparted to work part. So metal flow is constrained so that the flash is created. The flashless forging, the work part is completely constrained in the die. No excess flash is created. So the first one is open die forging. The figure shows the open die forging working. The components of the open die forging is there will be a lower die, it will be stationary. There is another one is upper die, this moving one. The workpiece is kept in between upper die and lower die, and the workpiece, when we apply the forces in upper die, the workpiece will be deformed. This is the open die forging. Impression, next one is impression die forging. The in die, here also like the open die forging, here also there will be two die, lower die and upper die. Lower die, as usual, the lower die is stationary, upper die is movable. Here the dies are having the cavity which impression we want to make on the workpiece. So the workpiece is kept in the in between lower die and upper die. When you apply the force on the upper die, force using upper die, the impression will be created. The excess material we can get as a flash. This is impression die forging. Then flash will be can be removed using machining process. Then flashless forging. In flashless forging, the die is stationary. There will be a punch. We will apply the force on the workpiece using this punch only. The workpiece is kept in the die. When you apply the force on the using the punch, the workpiece will be deformed into a recurved shape. This is a closed die forging, so there is no flash will be created, that is no excess material will be created in this flashless forging. In open die forging, compression of work part between two flat dies, similar to compression test when work part is cylindrical cross section and is compressed along with its axis. Deformation operation reduce the height and increase the diameter of the work. So common names of the open die forging is upsetting or upset forging. Open die forging with no friction. Homogeneous deformation of a cylindrical work part under ideal condition in an open die forging operation. So the first figure shows start of the work process. The workpiece kept in between the two dies, lower die and upper die. Here the original length, that is HO. Next one is second is we give the partial force. This is the partial compression is happening. The height is reduced, but the diameter is increased. In the third one is final output. We applied whole pressure on the workpiece. The height is reduced to HO from HF, final height. The diameter also increased. The open die forging with friction. The friction between work and die surfaces constrains lateral flow of work, resulting in barreling effect. In hot open die forging, effect is even more pronounced due to heat transfer at and near die surfaces. which cools the metals and increases its resistance to deformation. So this is the open. This figure shows open die forging with friction. In first figure shows the starting process. Initially, the diameter and height is original. Then we didn't apply the force. In second, we apply the force. So in figure we show the barreling effect. Okay. The final shape is showed in the third figure. Next one is impression die forging. Compression of work part by dies with the inverse of desired part shape. Flash is formed by metal that flows beyond die cavity into small gap between die plates. Flash must be lateral trimmed using machining process, but it serves an important function during compression. So the impression die forging, there is two dies, lower die and upper die. The workpiece kept between the lower and upper die, and the cavity is formed in these two dies, lower and upper dies. This is the shape which we want in the final output. Then first figure shows just the initial contact with the raw workpiece. Second one is partial compression. Then third one is final die closure. It causes flash to form a gap between die plates. The advantage and limitations of the impression die forging is, the advantages are, compared to machining from solid shot, it has a higher production rate, and it has a less waste of materials. The greater strength we can get from the impression die forging product. It's favorable grain orientation in the metal. The limitations are, it's not capable of close tolerances. Machining often required to achieve accuracies and features needed. The next one is precision forging or flashless forging. Compression of work in punch and die tooling whose cavity does not allow for flash. Starting work path volume must equal die cavity volume within very close tolerance. Process control more demanding than impression die forging. Best suited to part geometries that are simple and symmetrical. It's often classified as a precision forging process. This figure shows the working of flashless forging. So initially, in first figure, just before initial, it shows the initial contact with the workpiece. Second one is we apply the partial pressure, the partial compression is happening. Third one is final punch and die closing. Then forging hammers, also called draft hammers, apply impact load against the work part. There are two types of hammers, gravity draft hammers, power draft hammers. If you see the gravity draft hammers, impact energy from the falling weight of heavy ram. Using the gravitational force, we apply the force impact on the workpiece. Whereas power draft hammers, we accelerate the ram by pressurized air or steam to give the impact on the work part. Disadvantage is impact energy is transmitted through anvil into the floor of building. The vibration will be taken place. It will affect the work and machines. It's commonly used for impression die forging. Draft hammer, the figure shows the details of draft hammers. First one is head, the topmost is head, it's containing the cylinder. Next one is piston rod. This is structural members, that is frame. Ram is there. The last in bottom there is an anvil. The workpiece is kept between anvil and the ram. So using the piston rod and ram, we apply the pressure on this, impact on this workpiece. Forging process. To apply gradual process to accomplish compression operation, the forging process are used. The types of forging process are mechanical process, hydraulic press, screw press. Mechanical press, it converts rotation of drive motor into linear motion of ram. In hydraulic press, the hydraulic energy used to actuate the hydraulic piston, it's connected with the ram. In screw press, the screw mechanism drives the ram. Upsetting and heading. The forging process used to form heads on nails, boards and similar hardware products. More parts produced by upsetting than any other forging operation. It performed cold, warm or hot on machines called headers or formers. Wire or bar stock is fed into machine, the end is heated, then piece is cut into the length. For boards and screws, thread rolling is used then used to form threads on the bolts and screws. So this figure shows the working of upset forging. Initially, the first one is shows wire stock is fed to the stock. Then second one is gripping dies close on the stock and stock is retracted. So the workpiece will be kept in between these dies, gripping dies. There is a punch and the punch is moved forward to make the heads. Okay. It will give the force on this workpiece. The bottoms to form the head. So the final output will be like this. The fourth figure. Trimming after impression die is, you can the figure shows trimming operation, that is called, and that also called shearing process. It is used to remove flashes after impression die forging. So this is the final product of the impression die forging. There is a flash we want to remove. So we have the cutting edges, that is in the dies. So we get the workpiece on this dies. We use the punch to give the force on the workpiece. The flash will be removed. The next process, first we discuss the rolling, then we discuss the forging. Now we move on to extrusion process. In extrusion process, the compressive force is used to form the final product. So the compression forming process, in which work metal is forced to flow through a die opening to produce a desired cross-sectional shape. So the die opening have the cross-sectional shape, desired cross-sectional shape. So the work is flow through a die opening using the compressive force. The process is similar to squeezing toothpaste out of the toothpaste tube. So in general, extrusion is used to produce long parts to uniform cross sections. There are two basic types of extrusion. One is direct extrusion, another one is indirect extrusion. In the direct extrusion, the parts will be, first one is container. We kept the workpiece inside the container. There is a opening. Inside the container there is a die. In the die there is opening which has the desired shape of the final output. And there is a ram which is used to apply the compressive force on the workpiece. So when you kept the workpiece inside the first we have to keep the workpiece inside the container. Then we apply the pressure by using the ram and the workpiece. So that using this force, the workpiece will flow through this die opening. So the final output will be the shape of the die. This is a direct extrusion. It is also called forward extrusion. When in the direction of force applied, the final output will be come out. As ram approaches die opening, a small portion of billet remains that cannot be forced through a die opening. This extra portion is called but must be separated from extruded by cutting it just beyond the die exit. Starting billet cross section usually round. The final shape of extruded is determined by the shape of the die opening. If you want to make hollow and or semi-hollow shapes, you can use this kind of direct extrusion also. By it is same as the forward extrusion process. Here there is a die opening and also there is a mandrel in ram. So which used to form the hollow shape inside the pipes or product. So the figure A shows the working principle and parts of the direct extrusion is used to produce hollow or semi-hollow cross section. The final figure B shows the circular hollow shapes which is produced from this extrusion process. And the figure C shows the semicircular cross sections showed in this produced from this direct extrusion. Next one is indirect extrusion. Here in forward extrusion, the final output will flow in the direction where we apply the force. But here we apply the force in one direction. The work will flow, the final output will flow in opposite direction. So this is called indirect extrusion. The figure A shows there is a container. The workpiece is kept on inside the work billet is kept inside the container. There is a die. There is a opening. The die is connected with this ram. So when you apply the force on the ram, the work will flow the die opening in the opposite direction in which we apply the force. So the second one is to form the hollow cross section. You can use this kind of indirect extrusion also. So there is a container. We kept the work billet inside the container. There is a die which is connected with ram. So there is a gap between container and the die. This form the shape of the tube, hollow cross section. The advantages of extrusion: the variety of shapes is possible, especially in hot extrusion. So you can number of variety of shapes can be produced from this extrusion. Limitation means the part cross section must be uniform throughout the length. The grain structure and strength enhanced in cold and warm extrusion. The close tolerance are possible, especially in cold extrusion. In some operation, little or no waste of material. This is the difference, the comparison between hot and cold extrusion. In hot extrusion, it reduces strength but increases the ductility of the metal. It permits more size reduction and more complex shapes. to be produced. In cold extrusion, it is generally used to produce discrete parts. The term impact extrusion is used to indicate high speed cold extrusion. Extrusion ratio, also called the reduction ratio, it is defined Rx equal to A0 by AF. Where the Rx is extrusion ratio, AO is called cross-sectional area of starting billet or billet, and AF is final cross-sectional area of the extruded section. It applies to both direct and indirect extrusion. This figure shows some of the extrusion cross-sections. Next we go for the bulk deformation process, wire and bar drying. Cross section of a bar, rod or wire is reduced by pulling it through a die opening. Similar to the extrusion process, except the work is pulled through a die in the drying. It is pushed through in extrusion process. Although drying applies tensile stresses, compression also plays a significant role since metal is squeezed as it passes through die opening. Here, this figure shows the wire and bar drying. So, this is the process of drying of bar, rod or wire. So, there is a draw die. This is called a draw die. So, this is a starting stock workpiece. The diameter is DO. This is the final output, final diameter, final workpiece. When you pull the workpiece, then it comes through the draw die, so the cross-sectional area is changed. Formation, deformation is taking place. Area reduction drawing is the change in size of work is usually given by area reduction R equal to AO minus AF by AO. Whereas R is area reduction in drawing, AO is original area of work, AF is the final work. When you compare the wire drawing and bar drawing, difference between the bar drawing and wire drawing is stock size. In bar drawing, large diameter bar and rod stock is the final output, whereas the wire drawing, smaller diameter stock and wire sizes down to 0.03 mm, that is 0.001 inches are possible. Drawing practice and products are, drawing practice usually performed as cold working, most frequently used for round cross sections. The products you can get from drawing and wiring process, the electrical wire stock for fences, coat hangers and shopping carts. Rod stock for nails, screw, rivets and springs. The part stock can be used for machining, forging and other process. In bar drawing, it accompanies a single craft operation. The stock is pulled through one die opening. Beginning stock has large diameter and is a straight cylinder. It requires a batch type of operation. So this figure shows hydraulically operated drawing bench for drawing metal parts. So here this is a starting work. There is a hydraulic cylinder which is used to pull the bars through the die opening. This is a die stand. The drawn bars, the carriage is connected to hydraulic cylinder. So when you use the hydraulic cylinder, we pull the drawing bars through the die opening. The wire drawing, the continuous drawing machines consisting of multiple draw dies, typically 4 to 12, separated by accumulating drums. Each drum, that is also called capstan, provides proper force to draw wire stock through upstream die. Each die provides a small reduction, so desired total reduction is achieved by the series. Annealing sometimes required between dies to relieve the work hardening. So this is continuous work drawing. There is a multiple caps and drums are there. So initial wire stock, it is in the coil form. So it's pulled through the drawing dies, 2 dies. Okay. So this is called continuous drawing of wire. So when you prepare of work for drawing, you have to use the annealing to increase the ductility of stock. You have to do cleaning to prevent the damage to work surface and draw time, and pointing to reduce diameter of starting end to allow insertion through draw time. So in this lecture we discussed about the bulk deformation process. First we discuss about the rolling, then extrusion, then we discuss about forging, and finally we discuss about wire and